Have you ever felt like time speeds up or slows down depending on what you are doing? What if I told you that time itself actually behaves differently for people moving at incredibly fast speeds, like astronauts, or for those experiencing stronger gravity? Yes, time dilation really does affect astronauts, and it is not just science fiction. While the effects are very small, they are real and measurable, meaning astronauts returning from space are technically a tiny fraction of a second younger than they would have been had they stayed on Earth. This fascinating phenomenon is a direct consequence of Albert Einstein's theories of relativity. There are two main types of time dilation at play here. First, special relativity tells us that time slows down for objects that are moving very fast relative to another observer. The faster an astronaut travels through space, the slower their clock and their biological processes will run compared to someone stationary on Earth. Second, general relativity explains that gravity also affects the flow of time. A stronger gravitational field causes time to pass more slowly, so being further away from Earth's gravity, as astronauts are on the International Space Station, actually causes their time to speed up slightly compared to Earth's surface. For astronauts aboard the International Space Station, these two effects work in opposite directions. The station's high speed causes time to slow down for them, while its higher altitude, meaning weaker gravity, causes time to speed up. The speed effect is generally stronger than the gravity effect. Scientists use incredibly precise atomic clocks to measure these minute differences, and they constantly track how much time has truly passed for space travelers. In fact, time dilation is not just a theoretical curiosity for astronauts. It is a crucial consideration for practical technologies like the Global Positioning System, or GPS satellites in orbit move at high speeds and experience weaker gravity than on Earth. Without accounting for both types of time dilation, GPS devices would accumulate errors of many miles each day, making them completely useless. The satellite's clocks are carefully adjusted to compensate for these relativistic effects, ensuring your phone's navigation is always accurate. Ultimately, the real and measurable effects of time dilation mean that every journey into space is also a tiny journey into the future. While astronauts do not return as dramatically younger versions of themselves, the subtle shifts in their personal clocks provide profound evidence of the universe's incredible and intricate workings, confirming that time is indeed a relative experience rather than an absolute constant.